Hi, my friends and students. Welcome to this lesson. In this lesson, we are going to learn amazing facts about L.C.M. and what is the exact definition of L.C.M. What is the exact definition? What is the formal definition of L.C.M.? And I am going to reveal all the secret tricks, all the secret techniques to find the LCM. I'm going to reveal in this class now. That's right. So let us learn. Let us go into the this lesson. See, first, what is LCM? LCM is nothing but, as you know, that LCM is nothing but least common multiple. L for least and C for common and M for multiple. And also lowest common multiple also. In other words, we can say that. There is no doubt. Everyone knows. LCM stands for least common multiple. Then what is LCM? What is LCM? Every student is making mistake in form a definition to the LCM. Everyone says that least common multiple. What is exact definition of LCM? Let's see that. So today you'll get the clarity about the LCM now. Then LCM is nothing but, see, it is the least natural number which is the multiple of given numbers. The least natural number which is multiple of given numbers. For example, in a particular problem, if you want to find LCM of two or more numbers, that LCM would be the very least common multiples of given numbers. Got the point? LCM is nothing but it is the least common number, least natural number, which is a multiple of given numbers. Or nothing but, in other words, also we can say the definition, the least natural number, which is divisible by each of given numbers. Got the point? Let us see. Let us check this formula. Let us check this definition by taking one example now. Okay, I'm taking the two numbers. Okay, that two numbers, how we can find the LCM, then what is the role of the LCM, then we'll see that. Okay, least common multiple. See, I'm taking the two numbers, example 2 comma 8. 2 comma 8. I'm taking the two numbers that are 2 comma 8. Got the point? And also I am taking these tables. I don't mention here the direct method to find the LCM. Got the point? What is LCM? Let us learn that. In a clear definition, the definition, how we can apply this. Why? What is the role of the LCM? We can learn this. Let's see that. I'm taking the two table. You know, everyone is perfect two table. Okay, and I'm taking the 8 table also. 2 table and 8 table. Only just see, we are going to learn. We are going to learn the common definition. What is the formal definition? How can we apply to the numbers? Easily we can understand that. Now I am going to see the, let's see the once again least common multiple. Okay, 2 table, 2 1s are 2, 2 2s are 4, and 8 1s 8. Here see, the multiple of 8 starts from 8. That's why 8 must be the 8 must be the common multiple of given numbers. Other point. And there were one more number also, and 16 one more number, and here also 16. Other point. So we know that nothing but all even numbers are multiples of 2. So that's why these are all numbers of multiples of 8 are the multiples of 2. For example, if you take the 24, 24 means 2 12 the 24. 2 16 the 32. That's why every even number is a multiple of 2. What's the point? Okay. So here I am writing this one. See, the 8 comma and the 16 comma and 24, so on. These three are the three common multiples, first common multiples here. In these common multiples, we need to see the definition, see the least natural number which is divisible by each of given number. Yeah, we have taken two numbers 2 comma 8. Only just see, as these three are 18 and 16 and 24, these three are the numbers. These are all divisible by 2 and 8, each and even number. But Here, what is the LCM means? Here, the least one only LCM. Got the point? I think you have got idea about LCM now. Okay, only we need to take least. These three are the common multiples. Among them, we need to select least one. We need to consider the least natural number as LCM of the given numbers. Got the point? For example, I'm taking one more thing. See, and one more problem. For example, and I'm taking 12 comma 4. 12 comma 4. For example, 12 table. Uh, I'm writing the multiples of 12. 12. Sorry, and 24 and 12 to the 36 and 12 fours 48 and so on. I'm writing here multiples of 4 3 is 12 and 4 4 is 16, so on, and 4 5 is 20 and 4 6 is 24, so on. Here I have written some of the multiples here. Now let's take common multiples now. Let's take common multiples. See, as we know that the multiples of 12 starts from 12 and the multiples of 4 starts from 4. So I'm selecting C. Here 12 is the common multiple. I'm writing aside. And one more C, 24. I'm writing aside. And so on. What the point? So here see 12 comma 24. These two are there will be more multiples also. But see, these two I am taking now. 12 comma 24 means common multiples of 4 and 12 are started from 12 and infinity n. Okay. So here in these two numbers are divisible by these two numbers, each of two numbers. So 12 is divisible by 12 and 24 is also divisible by 12. And 12 is divisible by 4 and 24 also divisible by 4. So these two numbers divisible by each of given numbers. So in these, we need to take only the least one. So 12 is the exact uh, sum of given numbers. So 12 is the answer. So like this, we need to find the LCM, least common multiple. I think you got an idea about LCM. What is LCM? Exact definition of LCM. Again, I'm going to reveal the definition of LCM. The least natural number which is divisible by each of given numbers, or the least natural number which is multiple of given number, each of given number. Got the point? Okay. Now let's go to the amazing techniques to find least common multiple. You are going to enjoy this lesson, right? Hi, my dear friends and students. Welcome to this lesson. In the previous lesson, we have learned definition of what is the exact definition of LCM. In this lesson, we are going to learn the amazing techniques to find the least common multiple of the given numbers. Let's see how we can find LCM by using this amazing techniques. Let's see now. Technique one. which is called M technique. M technique is nothing but M for multiple. M for multiple. So how does it? How we can apply this technique to find LCM? Let us see now. So let us take one example. That is, I'm taking see LCM of 6 comma 12. LCM of 6 comma 12. We need to select the biggest number of the given numbers. So in this, see, easily we can find out the biggest number of is 12. So 12 is the biggest number. The second step is we need to see that we need to compare the biggest number with other numbers. How we can compare the biggest number with other? If the biggest number is a multiple of 6, then directly and you can write your ultimate answer as 12, the biggest number. Complete the two steps. The first step, the biggest number, and the second step is we need to number the answer ultimate can write the biggest. That's why the answer is for this problem is 12. Got the point? So as there are only two numbers, easily we have found the LCM of 6 comma 12. If there are three or more digits, does this technique apply to the next problem? Let's see now. Next problem. See, in the previous problem, we have taken only two numbers. In this problem, I am taking three numbers, 9, 18, and 36. Same, we need to apply the same steps here, my dear students. See, in this, as the first step, we need to see the biggest number. What is the biggest number here? So easily we can select that 36. Only there are only 9, 18, 36. Among this, only 36 is the biggest number. The biggest number. So B I'm writing as the biggest. Okay. So 36. And the second step, we need to see that whether the biggest number is multiple of others. Same. However, we have compared with the 6 with the 12. Same here, we need to compare the 9 and 18 with 36. Okay. So let's see the 9. We can cancel 36 with the 9. 36 goes 9 table in 4 times. So 9 for the 36. 9 ones are 9. 9 to the 18. 9 to the 27. 9 for 36. So 36 is the multiple of 9. And let's go to the 18. And easily we can understand twice of 18 is 36. So nothing but 18 twice is equal to 36. 18 twos are 36. So that's why 36 is also multiple of 18. Therefore, as 36 is multiple of 9 and 18 both, so here we can understand that 36 is our answer, as it is the multiple of the both other numbers. Got the point? What is the LCM of 9, 18, 36? 36. Got the point? Okay. Hi, my dear friends. Welcome to Technique 2. So, Technique 2 is nothing but co-prime method. Means if there are co-primes in the given problem, then what would be the technique to find the LCM? Let us see now. Okay. So before that, we need to see that what is co-prime. Got the point? What is the definition of co-prime? Okay. Let's see the definition of co-prime. See, my dear friends, if you take the two numbers, if they don't have any other factor except one as their common factor, then we can consider them as co-prime. For example, I'm taking an example now. See, I'm taking 4 comma 9. 4 comma 9. So let us see the factors of 4 comma 9. The factor of 4 is 1 and 2 and also 4. And factors of 9 are 1 and 3 and also 9. So just compare those factors. Let us select, let us take only the common factor now. The common factor only, we can see that that is only 1. Means the 4 comma 9 have common factor that is only 1. So that these 4 comma 9 are the coprimes. I think you have got an idea about coprimes now. Like that, we can take 3 comma 4. Every two consecutive numbers are coprimes only. Why? Because they have no common factor except 1. Got the point? See, in the given problem, if there is need of finding LCM of the coprimes, then what would be the technique? Let's see now. Okay. Let's see one example of finding the LCM. So LCM of 11 comma 13. Let's see. So 11 comma 13. So 11 and 13 are, so they don't have any common factor as they're odd numbers, and also moreover they are prime numbers. So they don't have any common factors except 1. That's why we can define them as coprimes now. So that's why whenever there are coprimes, their LCM is nothing but the product of given numbers. Simples. Got the point? So this LCM is, so LCM of the 11 and 13 is only just multiply them. 11 into 13. Nothing but 11 13s are how much? So 143. So 143. The product of 11 and 13 is just to multiply and just see that 13 and 11. So we can check here 39, 11. There is one shortcut method also to find the any number with 11. In the next class, next upcoming class, I am going to explain that secret also. Okay, you can learn that. But now I am revealing only the general method only. 11 threes, 33s, and 11 ones, 11, 11 plus 3, 14. So 143. 143 is the LCM of 11 and 13. So no doubt, my dear students, whenever there are two co-primes, just multiply them and write is answer as an LCM. For the point. So let's go to the next problem. If there are three co-primes, then what we have? Same. If there are three co-primes also same, we can multiply the three numbers to get their LCM. Okay, let's see that. Example 2. See, in the previous example, we have taken the only the two digits, sorry, two numbers. Now I am taking the three numbers. By So their LCM is, so just multiply them, 21 into 8 into 7. Just multiply them. So 21 8s are, so 8 1 8, 8 2 is 16. And again, just multiply with 7. 7 8 is 56. 7 6 are 42. 42 plus 5, 47. And 7 1 is 7. 7 plus 4, 11. So what is the answer, my dear friends? So the answer is 1176, means 1176 is that LCM. That's simple. Just multiply them directly. You can write as LCM. No need of doing synthesis division method. Okay. So that's all for this lesson. Let's go to the technique 3. Hi, my dear students. So welcome to this lesson. In the previous lesson, we have learned the technique 2 and technique 1. So in this lesson, we are going to learn the technique 3. Let's go into that. So the technique 3 is nothing but miscellaneous method. So what is the miscellaneous method? Let us see now. So by taking the example, in the example 1, the miscellaneous method, see how we can find the miscellaneous method now. Yeah, 3, 21 and 2, there are the three numbers are given in the problem. We need to find their LCM. In the same method, my dear friends, the first we need to take the biggest number of this. The 21 is the biggest number, and we need to check whether the given all other numbers are factors of 21 or not, or 21 is a multiple of other numbers or not. We need to check it. So here see, by 3, by dividing with 3, we get the 0 as a reminder. So 3 is a factor. Only just the other factors. Which are the factors? As 20, as 2 is not a factor here. So directly we can multiply with 2. And moreover, before multiplying, we need to see that whatever the non-factor thing is here, the non-factor thing, whether it is co-prime or not, also we need to see that. If it is co-prime, if it is co-prime, then we need to multiply that. If it is not a co-prime, then there will be another process in the example 3 I'm going to explain now. So in this process, as this is a co-prime, directly I multiply to get the LCM. Now 21 to is equal to 42. The 42 is the ultimate answer. So let's go to the next problem now. So in the example 2, LCM of 7, 14, 13. In the same process, here 14 is the biggest number. Easily you can say that 14 is the biggest number, and the 7 is the factor. That's why 7 is I'm cutting down, and the rest of the number is 13. As 13 is the co-prime of 14, so that's why directly I am multiplying 14 into 13. So by multiplying this, see 13 fours are 52, and that is 1 to 13, 13 plus 5, 18. So 182 is the LCM of 7, 14, 13. And let's go to the next problem now. In the example 3, so in the example 3, see we need to find the LCM of 8, 12, 16, and 4. So in this, see the same process, the first we need to see that the biggest number, that is 16. So, and we need to compare the other all numbers with 16, whether they are factors or not. So here 8 is the factor, so I'm cutting this factor, and 12 is not a factor, so I'm keeping it safe. And 4 is the factor, I'm cutting down. So the rest thing is only 12. So, and also we need to check it whether the 16, 12 are co-primes or not. So absolutely 16, 12 are not co-primes. Why? Because they have the common factors other than 1. So 4 is a common factor. So other than 1, and 2 is also common factor. That's why they are not co-primes. So in this process, what do you see? So we need to multiply the 16 with the least numbers to get the least common factors of, sorry, least common multiples of 16 and 12. So first I am taking the 2. So 16 twos are 32. And whatever we got here, and we need to set that whether it is a multiple of 12 or not, we need to see this. So absolutely 32 is not a multiple of 12. So we need to trial with another number. So let us take 3. 16 threes are 48. 16 threes are 48. So by trialing with 3, we got the 48, and also we need to check that whether it is a multiple of 12 or not. Yes, exactly. It is a multiple of 12. 12 fours are 48. So as here, 48 is the multiple of 16, and 48 is the multiple of 12, as it is least common multiple of 16 and 12. So the final answer is the 48 is the least common multiple of the given four numbers: 8, 12, 16, and 4. These are the three techniques were awesome techniques which are wherever we have never seen. By using these techniques, you can save the time in all the competitive examination. I think these techniques may help you to enlarge your knowledge. Thank you. Thank you very much.